Hey, fellow mathers. Before we get into this episode, we want to share with you how you can get access to free content, professional learning that will keep your students engaged and doing the math that matters. Get ready to go to this link, mathisfigureoutable.com/challenge.
That's right. Registration is open for the free Math is Figureoutable Challenge that's starting May 15th and runs to the 17th at 7 p.m. Central. We're going to have 3 nights jam-packed with learning and routines that you can take straight to your classroom.
In these challenges, we have a great time. We do some math, talk about classroom experiences, give away super cool bonuses and prizes. You won't just walk away with routines that are naturally engaging and encourage your students to think mathematically. You'll also have a chance to win over $6,000 worth in prizes, including a few virtual PD sessions for your school. I'll be joined by my wonderful co-host Kim and special guest Jenna Labe.
You can register at mathisfigureoutable.com/challenge for a fantastic learning experience. That's mathisfigureoutable.com/challenge. Now on to the show.
Hey, fellow mathematicians. Welcome to the podcast where math is figure-outable. I'm Pam and I'm laughing. Sorry.
I'm Kim and I'm laughing too.
And you found a place where math is not about memorizing and mimicking, waiting to be told or shown what to do, but it's about laughter and making sense of problems, noticing patterns, and reasoning using mathematical relationships. We can mentor students to think and reason like mathematicians. Not only are algorithms really not very helpful in teaching mathematics, but rotely repeating steps actually keep students from being the mathematicians they can be. Kim, I got to tell you, the other day I was talking, I think it was Chris Hogpen. Hey, Chris, the fantastic creator of Number Hive. And he said,
yes.
Yeah, we love Number Hive, right?
Yes.
In fact, my kid and I played it a ton the other day, and he's so funny. This is the one who's going into AI, computer science research. And he's like, his question was, I wonder how he created his hexagons.
Oh, yeah.
I was like, what? He goes, yeah, programming hexagons is super tricky. Anyway, it just went on. Which is kind of funny because I had just created a hexagonal grid in Illustrator. Anyway, so I was feeling his pain. But Chris, back to the point here. I'm all over the place. Chris said to me, "You don't pre-record your intros and outros."
Nope.
And I was like, "No, we re-say them every time." He's like, "I love that because I'm always listening. Like, is it gonna?" Well, there you go, Chris. Today that one was for you because I was laughing as the recording was starting, and then I just couldn't pull it
Most
together.
days we're just trying to pull it together.
Okay.
Hey, so we got another review, which I super love. It's my favorite thing to see.
Yay, reviews, people,
Yes,
more
love
reviews,
it.
more
It
reviews.
makes us
Spread
so
the word,
happy.
spread the word.
But leave nice ones. Those
Absolutely.
Okay, so this one's short, and it says, "This is an amazing capital letter podcast. I love it so much, and it really helps my 5th grade brain." Which, Pam, and it's from 783-59737 is the user who shared that with us. So, but listen, when I saw that, I thought, my 5th grade brain. Now it could be, it's summer maybe for some people, and so maybe it's my 5th grade teacher brain. But what if it's a 5th grader who listens? That happens, right? We have several people who say, "I listen in the car with my kids."
That would be cool. Yes.
783-59737. I kind of hope you're a 5th grader, and we love that you listen. Thank you so much.
That would be super cool. Yeah. So, and it's fantastic that your name is 783-59737.
Good job.
Well, it helped that you put spaces between them. Like in my notes right here, I've got them written so I can actually see. But I wonder if there's like a pattern in those numbers.
Right.
So contact us 783-59737 and tell us why you chose those numbers. We're super curious, especially if you're a 5th grader. We still like you if you're a 5th grade teacher, but it would be and so we would love to hear from everybody. It helps others find the podcast, and then we can keep spreading the word. Hey, Kim, I think we hit. In fact, I know we did. We hit 500,000 downloads the other day.
That's really cool.
That was really fun. That was a good benchmark. Bam.
It was a while ago,
it was actually it wasn't just the other day. It was a while ago. But yay for that. Cool.
Super cool. Okay, so let's get started. In the last episode, we started talking about 2 major ways to compare fractions, by looking at the numerator and by looking at the denominator. And I think maybe those aren't super uncommon for teachers to share
Mm-hmm.
with their students. And those examples are doable, they're figure outable, but we are going to suggest that some others are as well.
Yeah, absolutely. So let's talk about some other ways that we can compare fractions. And then if you want, you could hang them on a clothesline. We talked about clothesline math a little bit last time. I think we might emphasize that a little less today, more just the reasoning. So Kim, I'm going to give you a few problems.
Okie
You
dokie.
ready?
Yep.
Okay, first problem. What is bigger, 9/8 or 6/7? 9/8 or 6/7? Which one's bigger and how do you know?
9/8 is bigger because 9/8 is more than one whole. 8/8 is a whole, so 9/8 is more than that. And 6/7 is a little bit less than a whole because 7/7 would be a whole. So 6/6 is less than a whole.
So 6/7 is less than a
So
whole,
9/8
and
is bigger.
9/8 is greater than a whole.
Yep.
Yeah, so 9/8 is bigger than 6/7.
Yep.
Cool. Next problem. So Kim, what's bigger, 2/5 or 4/7? 2/5 or 4/7? Which one's
Oh, those are kind of
bigger?
ugly. Yeah.
Or how would you compare them?
2/5. Okay. So
Oh, thank you.
thanks for that. Um, 2/5 is a little bit less than a half. So 2.5 would be a half, equivalent to a half. So 2 is I like
Okay.
literally wrote a L. 2/5 is less than a half, and 4/7 is more than a half because 3.5/7 would be equivalent to a half. So 2/5 is a little less than a half. 4/7 is a little more than a half. And I think you asked me which one's more, so 4/7 would be more.
Nice. So kind of similar to the problem before, where 9/8
Yep.
and 6/7 you compared to 1, the number 1. This time you compared 2/5 and 4/7 to 1/2, and that since one was smaller than 1/2 and the other one was bigger than 1/2, then you could compare it that way based on that comparison of 1/2. I have to tell you, when you were talking, I was kind of writing like a clothesline math, like we did in the last episode. And I wrote, as soon as you said 1/2, I wrote it down. And you said something about 2/5 being less. So I wrote it to the left. And then you said, because 2.5 fifths is equal to 1/2. So I wrote
Yeah.
2.5 fifths under the 1/2. So I could kind of see 2/5 and then 1/2 and 2.5 fifths are in the same place. And then further to the right, I wrote 4/7. And then you said, because 3.5 sevenths is 1/2.
Nice.
So I wrote
Nice.
that underneath the 1/2 as well. So now my 1/2 looks like 1/2, 2.5
Yeah, that's
fifths,
great.
and 3.5 sevenths. Yeah? You know, Kim, that really brings out a point that came out in the workshop last week where people said, this is we're not only learning fractions, but we're also getting better at multiplication and
Equivalence.
division and even additive thinking, like, and big time equivalence. But being able to like think about 2.5 fifths and 3.5 sevenths has a lot. It's not just fractions. Like, we're really thinking about fractions multiplicatively, which is so important because they are multiplicative. Not about counting the numerator and counting the denominator and saying we're done with fractions. We got to do more than that. Okay, cool. Next question. How about, okay, I can't even read my own writing. 5/8 or 13/16? How would you compare those? 5/8 or 13/16?
You know what? The first thing I thought when you said 5/8 was like immediately I went, okay, we're a little more than a half. And then when you 13/16, I went, okay, we're still more than a half. So
Okay,
the half is not super.
trying to compare to a half. Yeah. Okay.
But if I think about comparing to 3/4, 6/8 is equivalent to 3/4. 5/8 is a little bit less than 3/4.
Okay.
And 12/16 is 3/4. So 13/16 would be a little more than 3/4. So I have one that's a little less than 3/4 and one that's a little more than 3/4.
So which one's greater?
13/16 is greater.
Cool. So if you were on a number line, which one would you see first coming from the left?
5/8.
Because that's smaller. So 5/8. So on my number line, the closed line that I've kind of written on my paper, I've got 5/8, and then next I have 3/4, and I have 6/8, and I have 12/16 all lined up in the same spot. And then next to that, I have 13/16. So I can kind of compare the 5/8 to the 6/8 and the 12 sixteenths to the 13 sixteenths. Nice. So it seems really helpful in all three of these problems that you could compare to a common nice fraction, a benchmark fraction. Does
Yeah,
that
absolutely.
sound
Yep.
like kind of what
A
you
little
did?
more, a little less.
Yeah, nice. Super cool. Okay, Kim, cool. Next problem. How would you compare 5/6 and 4/5? 5/6 and 4/5. Which one's greater? Or how would you compare them? How do they relate?
Okay, so the first thing I notice is that they are, how to say?
Mm-hmm.
Both of them are a unit fraction away from the whole. So 4/5 is just 1/5 away from a whole, and 5/6 is just 1/6 away from a whole.
Oh. And how's that helpful?
So, so if I put them on a number line and I think about starting at a whole, like,
The one.
and I want to go back the fifth
Mm-hmm.
to write, I'm drawing. So if I'm going to go back a fifth to record where 4/5 would be,
Mm-hmm.
or I go back a sixth to record where 5/6 would be,
Mm-hmm.
then 5/6 would be closer to the whole. It's only a sixth away from a whole.
Cool.
But 4/5 is a fifth
It's
away from a whole.
mm-hmm. And it sounds like to be able to do that, it's kind of like what we did in the last episode. You needed to be able to compare 1/5 and 1/6
Right.
to see how far back from the hole you were going to go. And then once you kind of land, if you went back a smaller bit, 1/6 is smaller than 1/5. If I'm sharing with 6 people, I get less, or if 6 of us are sharing, I get less than if 5 of us are sharing, right? So 1/6 is smaller, then that smaller 1/6 went not as far back from the 1. Therefore, the 5/6 was closer to the 1.
Yeah, and there's so many good things that are happening here because, at the same time, I'm thinking about 4/5 as 4/1/5 and 5/6 as 5/1/6. So I'm thinking about basically a scale up from the unit fraction. That's one thing that's happening. Then I'm also
Mm-hmm.
comparing a fifth and a sixth. So I'm getting a really good understanding of the relationship between amounts of unit fractions. And then
Mm-hmm.
I stuck it on a number line in order to think about like proximity to 1 and what it looks like to be a little bit less than 1 in varying amount, like in the versus a sixth of it or a fifth of it away. So
Mm-hmm.
within that one question of comparing fractions, I'm kind of wrestling with a lot of fraction understanding.
And building in that wrestle, that
Yes.
grapple, building that fraction understanding even better. And now we can have kids that can actually reason with fractions and not just repeating those crazy rules.
Yeah.
Nicely
Yeah.
done. All right, Kim, I think I have one more for
Okay.
you. How would you compare 3/4 and 29/30?
So I actually like this problem better than the one you gave me. So 3/4 is a fourth away from a whole,
Mm-hmm.
and 29/30 is 1/30th away from a whole. So they're both almost a whole, but 29/30 has to be bigger because it's just like a little sliver, a 30th to get to that whole. And it's like it's a tiny amount,
Just
yeah.
1/30
And
away.
3/4,
And the 3/4 is a
yeah.
whole fourth. It's a
Yep.
whole fourth
Yep.
away from the hole. Clear about that. That 3/4 plus that one more big whole fourth to get
Yep.
to the
Yep. Yep.
unit. Nice. It's a bit of a mind twist, eh?
Yes, it is. It is. So you're thinking about which one has a smaller amount to get to the whole.
Yeah, or another way of thinking of it is which unit fraction is smaller,
Oh,
therefore
yeah.
it's back less from the hole, therefore the 29/30, since 1/30 is smaller than 1/4, then 29/30 is going to be bigger than 3/4 because it's so much closer to it's a smaller unit fraction away from the hole, from the one.
And this is
Woo!
like a perfect example of how I'm super clear in my head about, like, I can picture it, I know it without question, but it's easy to get tangled up in your words when you're trying to justify it to somebody else.
Mm-hmm. And so models can be
Right.
really helpful,
Right.
and verbalizing it and get the words out tangled and have the person go, wait, what? And back and forth and forth and back until we all gain more clarity. And let's be clear, that is one reason why we use symbols.
Right.
We use symbols to represent these complex ideas. What doesn't work to mentor mathematicians is to just give kids the symbols and expect that all this deep meaning will come with the symbol. We have to build that deep meaning and represent it with the symbol. Okay, cool. Hey, Kim, I got to tell you, when we were preparing to film Building Powerful Fractions, my husband and I, we have a weekly date night. We go to our little handy dandy Tex-Mex place around the corner. It's called Garcia's. Super good chips and salsa. We actually had some queso the other day. I know you'd appreciate that, Kim. Right?
I
Your
want it
queso,
all.
right?
Chips, salsa, queso, not guacamole.
There you go.
Never.
No, yeah, that's right. You don't like guacamole. I'll take the guac, and I'll take it all. You won't have the guac anyway. As we were eating our chips and salsa and guac and queso the other day at Garcia's, he and I were talking about some of the things that we were doing in the workshop, and he reminded me that when I met him, he said something like, "Yeah, fractions are stupid. I turn everything to decimals, and I do it all in decimals." But the more that he and I have been married, and the more that we have talked, and as he did some of the fraction tasks, because he's like curious what we were doing, and so we were doing them over chips and salsa at dinner. The more that we were doing, it was so interesting that he said, so I could actually think in fractions. I don't have now I don't have to think in decimals. I can think in decimals, but I can also think in fractions. So y'all, if that's you, if you've kind of been stuck in one way that fractions have not been so figure outable for you, bam, like let's continue to think and reason, like last episode where we really focused on if you have the same numerator, the same number of pieces, then you can talk about the size of the piece. And if you have the same denominator, the same size of piece, then you can talk about the number of pieces. Or today, where we really compared to a benchmark fraction, benchmark number, and use that comparison. Or where we can think about if you're just one unit fraction away from the whole, then you can use that to compare. You can use these big ideas to really reason about fractions, because fractions are figure outable. One thing you need to know, that it's not real math when you're just doing a bunch of rote memorized procedures, but fractions are actually reasonable and figure outable. Thank you for tuning in and teaching more and more real math. To find out more about the Math is Figure Outable movement, visit mathisfigureoutable.com and keep helping us spread the word that math is figure outable. Thank you for listening and making math more figure outable.
To learn even more, make sure you register for our free challenge at mathisfigureoutable.com/challenge. You are not going to want to miss the evenings of May 15th through 17th, starting at 7 p.m. Central.
Math teaching, go register now. That's mathisfigureoutable.com/challenge. Join us to make math more and more figure outable. And if you can't join live, register and we'll send you access to the recordings. We'll see you there.